Here's a conservation momentum problem that involves two skaters. Now the two skaters are on this frictionless icy surface right here, and they're sort of stuck together or doing some maneuver where they're all sort of one unit. And what the problem states is that after one of these skaters here pushes off, so they have two different masses over here. Skater 1 over here will have mass M1, skater 2 will have mass M2. And they gave you a couple numbers here, like in particular M2 is bigger than M1. So this is the heavier skater right here. The heavier skater's over there. And what the problem states is that the heavier skater, which is this one over here, pushes off of this skater here and travels this 30-meter distance right here in 20 seconds. So it appears then that if this person here, this heavier skater, pushes off this one, they will leave here with a speed, say, of v2 of the 30 meters over the 20 seconds it takes them to glide across the ice and not hit the wall, but sort of come to the edge of the ice over there. So this information, the 30 divided by 20, just sort of gives you the speed of the skater after they've pushed off the other one. So if this skater is going to push off of this maneuver right here where they're stuck together and they go 30 meters in 20 seconds, that means they must have had a speed of 1.5 meters per second. Or in other words, after the push off, this heavier skater had a speed of 1.5 meters per second. And so what the problem wants to know then is, if that's true here, what was V1? So if this skater leaves this way with 1.5 meters per second, what was V1 going back the other way? It's a conservation momentum problem. We can write P initial x is equal to P final x. The reason why we're writing the x-axis is because it's a horizontal problem. There's no y motion, so we just focus on the x-coordinate in this case here. So, well, what is the initial momentum before the separation happens? Now, if you think about that for a minute, well, what is the momentum of both skaters before the separation happens? Well, they're sort of holding on to each other, so this skater isn't moving, this skater isn't moving, and they're not moving as a group. That means initial momentum is a big fat zero. They're not moving before the collision happens. Now, after the collision happens, of course, they push off each other, and what we've determined from the problem is that the heavier skater here, the M2, is going to move to the right with that speed V2. And yes, that V2 there is the 1.5 meters per second. Moves out like that. And well, if this skater moves to the right, this skater here is going to move to the left with his or her speed, so that'll be a minus M1 times V1. I'll sort of stop the problem now, but from this information, from this problem here, I think you are now free to solve for V1, which is the speed of this left skater after the collision.